Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, welcome to the platform of Noor School and College Mansehra for online classes of Physics grade 12. Dear students, today we are going to discuss the rectification and its types. As we know that we have gone through the topics of uh, rectification, and initially going into detail, I would like to have a very quick note on the rectification concept. Dear students, you can see that in the last lecture we discussed the rectification, and we defined rectification as the process of converting AC into DC by using diodes. This is the rectification, and we discussed the difference between AC and DC. We know that alternating current is the current which is called vibrating current, and the symbol of AC is this one, the circle and having a waveform in it. The property of alternating current is that the polarity of alternating source is changing with time. If, for example, this left terminal is positive and right is negative, after some time, in millisecond or microsecond, this positive terminal will change into negative and this negative will change into positive. When the polarity of this voltage source changes, then the direction of the current in the conductor also changes. We know that whenever alternating current is connected across the terminals of copper wire, the electrons vibrate means they perform to and fro motion. That is why it is called vibrating current. So alternating current is the vibrating current. This is the symbol, and the actual movement of the electron is vibratory. All the electrons, they vibrate back and forth. Similarly, when we discussed the DC, the direct current, we said that this is vibrational current because there is no vibration in the current. The symbol of DC was this one. After that, we discussed the graph of AC and DC. This was the graph of AC, the positive half cycle, negative half cycle, then again positive half cycle and negative half cycle. Positive half cycle means the electrons are moving in one direction. Negative means they come back. This is right, this is left. So this is when one cycle is completed, positive and negative, the electron moves forward and backward. It completes one vibration, again second vibration, again third vibration, and so on. As long as the electron is vibrating in the wire, we get this form: one cycle, two cycle, and three cycle, and so on. As far as the DC is concerned, direct current has the graph of almost linear. There is no negative portion of the graph. All what we have is the positive. Either it is pulsating like this or a straight line. Clear? Okay. This was the concept of rectification. Now we come across to the main topic to be discussed today. The topic name is rectification types. As you know that in rectification, the AC is converted into DC. Now we consider there are two types of rectification. One is half wave rectification and the other one is full wave rectification. Half wave rectification is the rectification in which only half portion of AC is converted into DC. In half wave rectification, only half portion of the AC is converted into DC. What do you mean by half portion? Half portion means we know that this is the graph of alternating positive, negative, and so on. Half portion means either we convert these positive top two half cycles into DC, or we may convert these bottom or negative two half cycles of the AC into DC. This is what we mean, only half portion. Half portion means either upper portion or lower portion. Now, this is the half wave rectification circuit. Consider this is the alternating current source. As we know that this is the symbol for AC, this is the symbol for transformer. This is primary coil, this is secondary coil. From one terminal of the output of this transformer coil, we connect a diode. The other terminal is connected with a load may be a resistor or a fan or a bulb or any other thing. Now you can see that this is the complete loop, this is the complete circle. Now you can see that when the upper terminal of alternating source is positive and this terminal is negative, due to this positive connection, the upper portion of the primary coil is also positive, and this terminal is negative because it is directly connected with the negative terminal of the battery. So this terminal is negative, this terminal is positive. Later on we will see that this positive will convert into negative and this negative will become positive. So these positive and negative will also change their direction. This terminal will become negative and this will become positive. Now you can see that this is the upper terminal of AC is positive, which is connected with the primary coil of transformer. That is why the upper terminal is positive, and lower terminal of the coil is negative because it is connected with the negative terminal of AC voltage source. What happens in the primary coil when magnetic flux changes? That flux is taken from primary coil to the secondary coil. So according to Lenz's law, the same poles appear here. The top terminal will be positive like this and the negative terminal will be negative like this. Okay, this is the secondary coil, this was the primary coil. Now you can see that in this circuit we connected diode right here. The P side of the diode is connected with positive. Now take this as positive. This positive is connected with P terminal of the diode and N is connected with the negative side. What do you mean? Is this diode forward or reverse? Definitely it is forward because P is connected with positive and N is connected with negative through this load resistor. Okay, what happens? We studied that whenever a diode is forward biased, it will conduct current. It means that the current will flow in this direction, in this through this diode the current will flow in this direction. Getting my point? Because this diode is forward biased, and it is forward biased because P is connected with this positive and N is connected with this negative terminal. Here it is written diode is forward biased, and you can see that P side of the diode is connected with positive and N side of the diode is connected with negative. This is called load, external resistor. This may be a bulb or a fan or something else. Okay, now consider this point. We know that the polarity of alternating current changes. In the upper this diagram, it is shown that the polarity, the top terminal, the polarity of top terminal of the AC is positive and this bottom is negative. But change them, make it negative, make it positive. Right here you can see that in the negative half cycle, when the upper portion becomes negative and lower portion becomes positive, what happens? The primary coil also changes its polarity. This side will become positive and this side will become negative. Can you see here? This side of the diode was this side of the primary coil was positive because it was connected with positive, and this side was negative because it was connected with negative. When the alternating voltage source changes its direction, positive becomes down and negative becomes up, like this. The polarity in the primary coil also changes. According to Lenz's law, the secondary coil will make the same polarity at the same side. This side of the secondary coil will be positive and this side will be negative. Something like this. You can see that this was positive in the primary coil, so this will be positive in the primary coil because of Lenz's law. Okay, what happens now? Right, in this figure you can see that now the diode is p side of the diode is connected with negative terminal, and n side of the diode is now connected with the positive terminal. What is this condition? Is it not reverse bias? Definitely this diode is reverse biased, because the P side of the diode is connected with negative and N side of the diode is connected with the positive terminal of secondary coil through the load. Now in this case this diode is reverse biased, and we know that whenever the diode is reverse biased it is off. You can say that this diode is in off state, and here this diode was in on state. Here due to forward bias this diode was on. Here due to reverse bias of the diode this diode is off. When it is off there will be no current passing through it. Current will be zero. No current will pass through the load. There is no current. And you can see that it is written diode is reverse bias. There is no current in the circuit. Now what happens? Look, as we know that this this was the alternating source. When we consider the half positive cycle, this half positive cycle represents this case, the upper portion positive, lower portion negative. When we consider the negative half cycle, this half cycle represents this one. Now the bottom side is positive and upper side is negative. Due to the change in polarity, once the diode is on the current is passing. For the negative polarity, for the negative half cycle, this diode is reverse bias or it is off. No current is passing through. Now as far as the graph is concerned, consider the graph. This upper graph is the input AC voltage source, and this lower graph represents the output AC source, sorry, DC source, output DC, because this rectifier will convert AC into DC. Now look, as we know that the pure form of the AC is this cyclic or in the wave form. This is the central point or mean point, which is called zero, and this is the timeline. As the time moves forward the polarity goes positive, then it goes negative. Negative means in opposite direction. Okay, now as far as the positive cycle is concerned, these two are the positive cycles and these two are the negative half cycles. When the positive half cycles are concerned, we know that positive half cycle means the direction of current. The direction is in the right. Here it is right. But here in the negative, the direction of the current will change. It will get reversed. Here it is right, then left, then right, then left. This is the representation of vibration. Look at this marker. For example, this marker goes right, I will take this positive. When this marker will get back, I will take it negative. Again, positive, negative, positive, negative. Or you may say up, down, up, down, up, down, or front, back. Getting my point? This graph represents the vibration. So this is input AC. Now consider this is take these as the reference points that I have drawn here as dashed line. When the current was going to the right, I am talking about this graph, then the diode conducts the current. So at the output I get the same current, the same half cycle. This is the same half cycle. Clear? Okay, now when I talk about this negative half cycle of the input, I mean this condition. when the polarity changes, positive becomes negative and negative becomes positive. When the diode becomes reverse bias, there is no current. No current, it means there is no output current in the load. I get here no output, neither down nor up, but the current is zero. Again, the positive polarity up and then zero. Then it will be up and then zero. Then it will be up and then zero. You consider here that you can see that this is the total portion of the AC, both positive, negative, positive, negative, positive, negative. But here I get only positive values and there is no negative values. That is why it is called half rectification. Half rectification means half of the wave is cut, half upper portion is allowed to go forward, but the negative portions are cut, they are removed, they are blocked, they are stopped. This is what we call half wave rectification. Clear? Okay. Now this was the half wave rectification. Now I would like to tell you the full wave rectification. The concept is same. Now you can see that, dear students, look here. Full wave rectification, the process in which both the positive and negative cycles are converted into DC. Here in the half cycles we considered only half positive cycle of the input AC, but in full wave rectification we will convert both positive and negative cycles. They both are converted into DC. Okay, how? Look here, look again at this example, this diagram with a little bit change. This is alternating current source, this is also alternating current source. This is for positive half cycle, this is for negative half cycle. How positive and negative? Look here, this is the positive terminal, this is the negative, but in the next cycle this positive will become negative, this one, and this negative will become positive, this one. Initially, due to this positive, this terminal will be positive of the primary coil and this side of the primary coil will be negative. Clear? Now this is the primary coil and this is the secondary coil. Now you consider that in the full wave rectification we use two diodes. This is upper diode, this is downward diode. Upper diode is connected with this wire and the lower diode is connected with this wire. Okay, now the output of this diode and this diode, they are connected right here. You can consider that when the current will pass through this side and when the current will pass through this side, they both current will join here, they will pass through the load, and when from the other side of the load this current will go this way and they will go back into the this secondary coil. This is called center tape transformer. This center tape transformer has three wires instead of two. One wire is this one, second one is this one, and the third wire is this one. Clear? Okay. Now you can see that again. I would like to tell you that for the positive half cycle, consider that the upper terminal of the AC voltage source is positive and negative terminal is this one. This is positive and this line is connected with the upper side of the primary coil, so this side is positive and this side of the coil is negative because it is connected with negative. Clear? Okay, come on this side. In the secondary coil, according to Lenz's law, the same poles will appear. Here it was positive, this side of the secondary coil will be positive and this side of the primary is negative. That is why this side of the secondary will also be negative. They will have the same polarity. This is if this is positive. For example, if this is positive, so this portion and this portion, all three will be having the same polarity. Similarly, if this side of AC is negative, so the primary and secondary will have the same polarity. Now what happens? Now here we consider both the diodes because two diodes are connected. When you can see that the P side of this diode, the upper diode, P side of this diode is connected with positive. So this diode is forward biased, and come to this diode. The p side of this second diode is now connected with the negative. Now this diode is reverse bias. Getting my point? Because p is connected with negative, while this first diode is forward biased because the p side of this diode is connected with the positive terminal. So this diode is forward and the second diode is reverse. If the first diode, the upper diode or this diode is forward, it will allow the current pass through it. Clear? And if this diode is reverse, it will not allow the current to pass through it because it is reverse bias, and whenever the diode is reverse bias, it is switched off. So look here, this is the load. It means that in the positive half cycle, the current is passing through upper diode and this current is passing through the load and it gets back into the transformer. So the upper loop is completed. This loop is completed. Clear? Now you can see that now the upper portion or the upper terminal of the load will be positive. Getting my point? Because this positive current is coming this way, so this portion will be positive, and for the reference we assign negative sign to this portion, for because for positive there is always negative. This is positive, this is negative, this is middle point, or it is referred to as negative. Now the upper point of load is positive for positive cycle. When we are talking about the positive cycle, the upper portion, this side is positive. Keep this in your mind. Now coming to the negative half cycle, we know that in the negative half cycle, this side or this terminal will become positive and this terminal will become negative. Look here, at the positive half cycle, this was positive, this was negative. Just change them. So the upper positive will become negative and negative will become positive. Now this portion and this portion, they will have the same polarity. If this is positive, this is positive, this is positive. Now this is negative, negative and negative. Now the upper diode is reverse biased because the p side of diode is now connected with negative. So now the upper diode is reversed and down, and the lower diode is forward because the p side of the diode is now connected with positive from this side. So this diode will allow the current, but this diode will become off. When this will become off, there will be no passage of current. The current will pass only through this diode. But look, when this current goes through this second diode, this diode is connected with the upper one through this point. We know that this current will go this point and the current wants to come back to complete the loop, but as we know that this diode is reverse, this diode will not allow the current to pass this way. So the current has only this direction. This current, when the current this current I is moving at this point, there is no way going back, but the way is available right here. Again you can see that for the negative half cycle, the upper point of the load is again positive. Look here, it was positive for the positive cycle and it is again positive for the negative cycle. So upper point of the load is again positive for negative cycle. What does it mean? It means that when we apply the alternating current, we get the DC. DC means there is no change in the polarity. This polarity remains same. Top positive, down negative. Again, top positive, down negative. The input polarity, positive or negative, may change, but the output polarity will remain same. This is what we call the change of AC into DC. Now if you look at the graph, this is the input graph, positive, negative, positive, negative, and you can see that this positive, no problem, like the half wave rectification, this is rectified, we get this one. But what about this one? This is the negative. When you can see that when the current was negative, this current was connected right here, so that this current goes through the second diode, goes up and to the right. So this current does not get right here, but this current is getting to the upper point. The current is negative but it gets to this point. That is why the negative half cycle is converted as positive, and positive is again positive, negative is also made positive. This is called full wave rectification. I hope students you will be able to understand this concept. So please do your research and make some notes. Thank you very much.